over how to graph, write coordinate rules, and map out different types of composite rigid motion. So composite meaning when more than one happens. So for problem number 1, we are given triangle PQR, and it says reflect triangle PQR over the y-axis. That's our first composite, or first transformation, so we're going to reflect over the y-axis. Let's go ahead and highlight that. And then we are going to translate right 3 and down 4. So first we're reflecting, and then we're translating. So if we're reflecting over the y-axis, I'm going to go ahead and draw in our line of reflection, which is our y-axis here. And all points are reflecting over it. So if point P is 2 units to the left of the y-axis, then P prime will be 2 units to the right. So there will be P prime. Point Q is 1 unit to the right, so Q prime will be 1 unit to the left. And point R is 1, 2, 3, 4 units to the right, so R prime is going to be 4 units to the left. And once we have graphed the points of our image, we can go ahead and connect those to make our triangle. So what we have here is our first image, which is triangle P prime, Q prime, R prime. Now we want to go ahead and graph our translated image. So I'm going to do our translated image in yellow on the same graph. So now it's going to translate our image to find our double image or composite rigid motion. So it's going to the right 3 and down 4. So point P is going to move to the right 1, 2, 3 units, and then down 1, 2, 3, 4 units, and that will be our point P prime. Q is going to move to the right 3, so 1, 2, 3, and down 4, 1, 2, 3, 4, and that is our point Q prime. And R is moving to the right 3, 1, 2, 3, and down 1, 2, 3, 4, and there is our point R prime. And actually, sorry, these should be all labeled double prime because this is our second image. Sorry about that. And so we've now graphed triangle PQR reflected over the y-axis and translated to the right 3 and down 4. It's helpful to graph both of the rigid motions on the same graph. Don't try to do them both in one step. So the next part asks us to write a coordinate rule. So for our coordinate rule, we need to think about first what happened when we reflected our points over the y-axis. Let's start by taking a look at our point P and P prime and comparing their coordinates. The point P is located at -2, 5, and P prime is located at +2, 5. We've looked at this before when looking at reflections over the y-axis, but as you can see, our x value goes from negative to positive, and if it were positive, it would go to negative, so it became its opposite. So our x value is becoming opposite, which we express as -x, and our y value stays the same, so y. However, we're not done yet, because in this case, a second transformation happens. Let's now compare P prime to P double prime. P prime is now located at 5, 1. And if we compare our x values, we know a translation happened, and it moved 3 units to the right. So within our coordinate rule, we're going to write -x, then +3. And our y stayed the same, but then it went 4 units down, so it's going to be -4. And we've now written a coordinate rule that maps out this composite transformation. Let's go ahead and take a look at our next type of transformation. Tracing paper at home. This would be a great time to use it for your rotation. However, I'm going to go ahead and show you how we can do our rotation without using our tracing paper. So remember, when we're rotating 180 degrees, let's start by, I'll highlight that. We're going to rotate 180 degrees about the origin, and then we are going to reflect over the line y equals 2. So remember, when rotating, it doesn't matter if you go to the left or right when you have 180 degrees, because both will be the same. So I'm going to rotate to the right. So for point A, 1, 2, 3, 4, 5, 6 units to the left, and I'm going 3 units up. This entire shape is going to rotate, because here it's 90 degrees. So if it rotated 90 degrees, it would be going 6 units up, and then 3 to the right here. And so now it's going to be here 6 units this direction, and then 3 down. And so this is going to be our point A prime. Let's look at point D. Point D is going 3 to the left, 6 units up. So now this whole thing is going to rotate. If it rotates 90 degrees, it'll line up with our axes again, and it would be up 3 and to the right 6. And if it rotates one more time, it's going to go to the right 3 and down 6. And that will be our point D prime. Let's do point B. We're going to go to the left 6 units, and we're going to go up 5 units. And that's going to rotate. So it's now going to go up 6 to the right 5. And it's going to rotate one more time, and it's going to go to the right 6. And then it's going to go down 5. And there is our point B prime. And we can kind of use the shape here to go ahead and figure out where would point C go. So this is A, D, and C is going to go next to it here, because they are 1 unit apart there, so they're going to be 1 unit apart here, and we can connect. You could also do the same process for point C if that was hard to visualize. So there is my first image, and now it's going to reflect over the line y equals 2. So let's go ahead and draw in our line of reflection. Y equals 2 is going to be a horizontal line where all y values are equal to 2. So now we want to think about how far above and below are each point of A prime, B prime, C prime, D prime, to think about how far above it will reflect. If we look at point A, we're going to go down 1, 2, 3, 4, 5 units. So point A double prime is going to be 1, 2, 3, 4, 5 above here. So there is A double prime. B went down from our line of reflection 1, 2, 3, 4, 5, 6, 7. So B double prime is going to be 1, 2, 3, 4, 5, 6, 7 above. Point D went down 8. So point D prime is going to be 1, 2, 3, 4, 5, 6, 7, 8 above. And C prime went down 9. It's a little bit off our graph here, but that's okay. D double prime, C double prime. We can connect. And there is our composite transformation. The last example that we're going to look at is how we can write our own composite transformation rules when we are given the pre-image as well as the image. What we're going to do is we are going to think about what would allow this to flip the direction and then shift where it's located. So it's going to be some combination of a reflection and a translation. And so there's quite a few different options we can come up with, but we're going to go ahead and kind of choose one to go with. So let's say that we were to reflect over this line here. And sometimes it's also helpful to graph that middle image on the plane, even though it's not given. So this would be C prime. Point B would be 2 to the right, so this would be B prime. And underneath that, we would have A prime if it were to do this reflection. And so this is a reflection. So triangle ABC reflects over the line. And when it's a vertical line, that is an x equals line, so it's x equals 2. After that, so then it, we can see that it's just shifting, so that's what we call a translation. It translates, and let's see by how much. It translates to the right. It went to the right. It goes from 4 to 6, so right 2 units, and it goes down from 4 to 2, and down 2 units. Now this is not the only transformation we could have come up with here. So you maybe have noticed a different one, but let's go ahead and look at one more together. Maybe you want to do your translation first, so let's maybe try that. So if I were to translate it, I could go to the right 2 units, and I will go down 2 units. So let's go ahead and graph each of those points. So I could go to the right 2 and down 2, which would be point C prime, to the right 2 and down 2, and this would be A prime. So triangle ABC translates to the right 2 units and down 2 units. Now once again, it's going to reflect. We can see that it is reflecting over this line that goes through the x-axis at 4. So then it reflects over the line x equals 4. And so whenever you're writing your own composite transformation, it doesn't always just work to just flip their order. The rules often change if you start to change the order that the transformations occur in. Hopefully this video has helped you understand how to graph, write coordinate rules, and descriptions for composite transformations.